Okay, cool. Hey everyone. This talk is called Building Cross-Domain dApps, which are called XApps, or zaps, as we like to call it. So first of all, a little introduction. My name is Rahul, and I'm one of the co-founders and the tech lead at Connext. We've been going at this since 2017, and we are basically one of the first teams that have developed interop solutions. So excited to show you guys how it works. So first of all, what is cross-domain? So there's been a lot of talk about cross-chain, multi-chain, but really if you think about it, these are domains. So they're not necessarily chains. Sometimes you can have things like roll-ups and other L2s. So basically what a domain is it's an execution environment. So this could be a layer 1, it could be another layer 2, it could be a side chain, could be something that's not even EVM. So everything like that is just looped into something called a domain. And an XApp or a zap is a cross-domain native dApp. So chill me on why zaps should be a thing. So one reason is, as a dApp developer, you don't really want to pick a winning L1 or L2. You want to just be able to deploy your app everywhere and then let users choose how they want to use it, or kind of abstract that whole interface away. And then no matter what execution environment ends up winning or being around in 10, 20 years, you know your dApp will always work. And users gonna use, so no matter what, Vitalik has talked a lot about cross-chain, multi-chain, and the benefits and merits of both. Sorry, looks like some feedback here. But in the end, users are just gonna keep using these things. And what we want to do with Connext is we want to build an environment where users can use these things safely, no matter what. So when you build a cross-domain app, you build it for users that are going to use these no matter what. And since this is an ETH conference, there might be ETH maxis in the house. So how do you reconcile this with all these different layer 1s? Well, if you create one of these zaps that contains layer 1 and ETH layer 2s, then you can actually value sync back to ETH and layer 2. So you have this cross-domain app that is working on all these different layer 1s and layer 2s, and in the end, you can actually bring value back onto the Ethereum ecosystem. And at the end of the day, these domains are a lot cheaper, so you can onboard users from anywhere and cheaply. So some users are currently priced out of ETH, some users are even priced out of Optimism and Arbitrum. But if you onboard them from other chains, you can cheaply do this and get them into the ecosystem. But security, so this is a big thing now in the space because bridges have been getting hacked left and right. So the main thing about security in this context is don't use trusted bridges. You don't want your bridge to be the point of failure in the system. So if your bridge is not the failure point in the system, then your domain becomes the failure point. So as a dApp developer who's developing on different domains, you need to actually understand the risks of the domains that you're supporting. So my co-founder Lane has a talk coming up in a few minutes where she will go over the security much better, and I won't front run her talk. Okay, is that better? Cool. So the thing is, cross-domain deployments are already here. So you can see in a lot of these very popular dApps like Aave, for example, SushiSwap, DEXs, lending protocols, they all have these kind of interfaces for multi-chain deployment. So you can already go and use all these apps on different chains. But if anybody has used these, you know that they're they're basically different apps and they're siloed from each other. So there's a lot of ways that we can actually improve on the Zap interface. So unifying the interface, of course, where you make one interface that you can interact with no matter what chain you're on. You abstract the bridging process completely from the users. That way users don't have to think about bridging or what chain to go to and from, how to move the value. All that is contained within the app. And this is the most important part, pass call data. So users are coming from different chains. They're not going to have gas funds on all these different chains. And if you really want to unify this, you want to pass the call data so that you can have this relayer-based system that basically does all the operations on the receiving domain. I'll go more into this a little bit later. So this, Abracadabra is a protocol that is built by, Frog Nation, has a lot of weird stuff going on. I won't get into that, but the protocol itself, so this degen box strategy used by Abracadabra is really cool, I think, because this is an example of how the bridging is completely abstracted, the domains are completely abstracted. What you do is you deposit collateral as UST on Ethereum. In the background, the protocol actually does all the bridging for you and then allows you to borrow against it. And then when you withdraw, for example, it also bridges back and lets you withdraw. So I like to call this protocol-controlled bridging, where the users are not in charge of the bridging anymore. That dApp itself and the protocol does this all in an automated way. And this is really how bridging becomes more sustainable for users and bridges as well, because you don't get long tail usage anymore. You get this huge usage from the protocol itself. So what can actually be built here? So cross-domain zaps, this is like LP zaps, so where you have asset on one chain, you zap it into a farm on another chain, where you can do things like split it into the LP and then deposit it directly, all through, abstracted away from the user. Cross-domain governance, this is another big thing, governance protocols are now starting to experiment with this stuff. Right now, mostly governance centralized on one chain. So if you have curve tokens on Ethereum and curve tokens on Arbitrum, you can't vote with your curve tokens on Arbitrum. So this is something that, apps should start to enable when they go cross-domain native. Yield optimizing across chain, since there's different yields, then you can start to get into things where you can provide the best yields for users. DEX arbitrage, of course, self-explanatory. Cross-domain borrowing, this is a concept like the Abracadabra concept, where you put in funds from one chain, you get yields on another chain, you're able to borrow against the funds that are bridged on ascending domain. And of course, I think we've barely started to scratch the surface of what you can do with cross-domain. So, we at Connext want to build the tools to make this stuff possible. So challenges as a dApp developer, building dApps is pretty hard in general. There's a lot of stuff moving around, and when you add more domains, you kind of exponentially increase that complexity. So everything from deploying contracts to multiple chains, getting RPCs, getting gas fees, managing deployed addresses. You have a huge list of addresses now. How do you manage that? A lot of dApps have this stuff hard-coded, and I think there's better ways to do it where you can automatically generate deployment files and artifacts. Reading and writing to chains, RPCs, of course, that just, all that stuff is just exponentially more complicated. And complex user interactions. This is the big one where you really want to simplify the complexity at the layer of the dApp. But that, of course, becomes a big challenge with different domains. So with Connext, what we are trying to do is we're trying to build a unified smart contract interface for X-domain native apps. This means that you can use Connext to basically let you choose exactly how you want to do the cross-domain stuff, and you have a single unified interface, and you don't really have to think about this stuff as a dApp developer. We also provide instant liquidity bridging and call data passing. So that goes back to what I was saying earlier about abstracting the gas stuff away from the user by letting the protocol actually take care of calling the function on the receiving chain through real layer networks and whatnot. Message passing, so this is something that we are heavily working on and about to release. But unidirectional message passing means you can trustlessly pass a message from one chain to another chain and verify that it comes from a source that is trusted. So if you want to vote from one chain to another chain, you can actually do that in a trustworthy way. Bidirectional, for example, if you want to read a TWAP price from one chain to another chain, you basically need to send a request to that chain and then get a result back. That kind of stuff is still very much in the infancy and has not been explored, but we provide the tools for that. And some of the challenges I addressed before about deploying contracts, subgraphs, repos, things like that, the complexity around this cross-domain management will be kind of abstracted away from dApp developers by the Connext toolkits. So kind of going into how an actual zap works. So here you have a sending domain and you have a receiving domain. So these can be two separate chains, L2s, whatever. So from the dApp's point of view, all they need to do is basically write these two smart contracts. So a cross-domain deposit contract, this is for example, like a Aave deposit. So in the cross-domain deposit, it will call, on the sending chain, it will call our unified interface, which is the transaction manager, which also lives on the sending chain. So all the stuff at the bottom here is all the Connext protocol bridge stuff. Then this transaction will get picked up by a router, which is the liquidity provider on the Connext bridging protocol, which then transfers through to the transaction manager on the receiving side. So the router will end up calling a function on the receiving side, which calls a fulfill interpreter, which ends up having the call data that you pass through. I'll show this all in code. It might make a little more sense. But at the end of the day, this fulfill interpreter will call your cross-domain middleware contract on the receiving side, and then you'll end up calling to your external, like, lending pool contract, let's say. So we can see some code now. All this code is public on the GitHub. So this, we're trying to build these starter kits for this stuff. So if we dive into things here, sorry, pull this up. Here's the cross-domain deposit contract. So another hard thing about building zaps is when you're building these contracts, you have to think a lot about what chain you're on. So this is on the sending side chain. So the dApp will basically call this function called deposit. It will use a token, an origin domain, and a destination amount. Oh, so first in the constructor, basically what you have to define is you have to define your transaction manager. This is the address of the Connext smart contract on the sending chain. Then basically you have a mapping of domains to pools. Since we're using like an Aave deposit in this example, you're going to have a mapping of which domain in Aave, like for example, sorry. Oh, shoot. Sorry about that. Thank you. That better? Okay. Yeah, good call. So for example, you'll have like a mapping of the domain for Polygon with the pool for Polygon and so on and so forth. So this contract will contain all those mappings. So then when you call a deposit on the sender side, it will look up your pool, make sure it exists. For example, if you're calling this on Polygon, you want to ape into the Avalanche lending pool, it will look up the Avalanche lending pool to make sure on the destination that it exists. And then it will encode the selector for the deposit function, which is going to be your middleware contract. And then it will set that as the call data. So encode with selector is how you encode a call for a contract call that happens in a different contract. So here, getting here on the receiver side, so now when this function is called on this receiving side contract, it basically the way the Connext architecture works, so let me go back here. So the fulfill interpreter is going to get the funds. This is the bridge contract, and then it is going to have the funds, and then it will allow this contract, which is called, to have access to these funds. So it will do an approval for these funds, and then this contract can be written to basically take those funds and do whatever it wants with them. So in this case, what we're going to do is we're going to take the amount, which is the balance of the message.sender, because message.sender is this bridge contract in this case. It will transfer the funds to this contract, then it will approve for the lending pool, and then it will deposit into the lending pool. So this is basically a very simple wrapper contract around getting the funds directly from the bridge and to that. So maybe your question might be, why can't you just directly encode the deposit to Aave function directly in here? And the reason that you can't do that is because you don't know the exact amount that you're going to get on the receiving side until the exact time of the bridging. Because the way the Connext bridge works is the gas fees are basically paid out of the amount that the user bridges. So you basically need to use this kind of wrapper contract, helper contract, to be able to get the exact balance that the bridge gave you, and then transfer the funds from there, and then you know the amount here, so then you can just deposit it directly into Aave. So, yep, that's about it for that. We are still early in this process of redesigning the Connext protocol. We're really eager to onboard developers who want to build these, and we want to work with you guys to build out these interfaces in the best way possible. So whoever wants to build a dApp, please get in touch with us, or a zap, and then we can help you through this, and we can work together and come up with the best interfaces to make this as native and abstracted as possible. So thanks, everyone.